Space rocks are ancient observers of our nearby planet group. NASA ran over a space rock and found something totally startling. Space rocks are puzzling items. They are observers to the beginning of life, but they can also wipe out our human civilization in an instant. What would happen if one of these heavenly bodies were to crash into Earth? Would we truly be able to defend ourselves, or are our governments deceiving us into a misguided sense of security to prevent the inevitable? NASA launched the DART mission for the first time. Humanity succeeded in pushing a space rock off its course. With this success, NASA has made history. The course of a space rock was intentionally altered so that we have any hope of saving our species in an emergency. If a space rock several kilometers wide were to hit Earth, a huge portion of the planet would be destroyed in a very short time frame. Significant damage and the launch of Earth's outer crust would completely change the remainder of the planet. In the following hours, we humans could potentially be history. Exactly that happened millions of years ago with the impact of the Chicxulub space rock. The dinosaurs vanished from Earth forever. Humankind needs to do something if it doesn't want to be wiped off the face of the Earth one day, just like the dinosaurs. The next big space rock will come, that much is clearly evident. In the face of this savage certainty, we must all use our technological abilities to build a functional space rock defense. Around a dozen missions from global space organizations and countries have already visited space rocks in the solar system. The Japanese Hayabusa mission provided notable data and even samples from the space rock Itokawa between 2003 and 2010. NASA's OSIRIS-REx mission gathered samples from the space rock Bennu in 2016 and is currently en route to Apophis, one of the most dangerous space rocks to date. ESA is also heavily involved in space rock and comet research. The Rosetta mission reached Comet 67P Churyumov-Gerasimenko and even sent a lander there. DART was the highlight of the mission. The test crashed directly into the surface of the space rock Dimorphos and pushed it out of its orbit. DART, the pioneer of space rock defense. It sounds like a science fiction situation, a massive test on an immediate course to a space rock to change the fate of humankind. DART, NASA's Double Asteroid Redirection Test Project, did just that. It may sound a bit excessive, but this test could indeed save our lives. The threat is not inevitable, but it could happen quicker than we realize. If a space rock were to come close to Earth, we might have only a few hours to prepare. DART replacements might one day save our lives. The lessons learned from the scientific accuracy and technological advancements of this mission are already part of our space rock defense. Why is this mission so significant, and what startling discoveries did the impact with Dimorphos reveal? The story of DART shows us in a terrifying way how thin the line between danger and protection can be. The path of the Double Asteroid Redirection Test was clear. The expensive test was built to be destroyed. The space rock Dimorphos was the target, and of course, DART was never intended to return. The mission was launched on November 24, 2021, at 1:20 a.m. local time from Space Launch Complex 4 at Vandenberg Space Force Base in California. The mission's goal was officially planetary defense by kinetic impact. In simple terms, this meant that the DART test was to impact the space rock moon Dimorphos in the Didymos system by a direct impact in such a way that it would be pushed out of its orbit. In an emergency, this would be the best strategy for protection. The reason why this approach is considered the best by experts is simply that only a kinetic impact can change the course of a space rock so precisely and controllably without increasing the risks. On the other hand, exploding a space rock could cause more problems than solutions. The blast could break the space rock into many smaller pieces, and these still very dangerous fragments could then rush wildly toward Earth. An alternative solution in an emergency is to tow space rocks using spacecraft. In this approach, one or more spacecraft would dock with the space rock and slowly pull it out of the collision course through continuous push. This strategy is also theoretically effective, but it would require extremely precise calculations and long-term planning to be truly successful. What is certain is that, if it comes to push, we must steer potentially dangerous objects so that they don't hit Earth. Fortunately, this can be accomplished with just a few meters of deviation. The earlier we find the space rock or comet, the easier it is to change its orbit with little effort so that it no longer poses a threat to us. The success of DART was so monumental that for the first time, the orbit of a space rock was successfully altered by a kinetic impact. so we would be safe in the event of a real threat. The impact caused a 100-meter-high cloud of dust and debris. It was nearly silent at NASA when DART rammed into Dimorphos at a speed of 6.6 kilometers per second. Experts and governments all over the world were involved in witnessing the event. At first, no one knew if the impact had truly achieved the desired result. A 100-meter-high haze of debris clouded the view. DART's camera was shooting until just before the impact, but at the moment of impact, the footage was interrupted to document the event. After all, the Laia block test, launched in 2022, was accompanying the spacecraft to this unique event. The Italian Space Agency had contributed the test to record the impact even after DART had already been shattered into 1,000 pieces. The test captured the entire impact from a safe distance. The pictures show the 100-meter-high dust storm and debris after the impact when the test collided with the surface at a speed of around 22,000 kilometers per hour. KMPH at first swelled up to such an extent, material that the whole space rock became imperceptible. Strain stayed high in the NASA control community for some time. The only thing that was sure was that DART had raised a ruckus around town. Anyway, the significance of a test hitting its objective with an accuracy of a few meters shouldn't be misjudged. On account of dynamic space rock safeguard, beginning information from Laia solid shape and the many telescopes that noticed the effect from Earth soon uncovered the mind-blowing result. After intensive examination, it was clearly evident that the active influence had changed Doris' circle undeniably more than initially planned. The asteroid moon's orbital period was abbreviated by precisely 33 minutes and 15 seconds. It was clear that this mission was not just a complete achievement but would be the basis of our planetary insurance techniques right up to the present day. The information from the Italian test continues to give important insights that assist researchers in better understanding the elements and impacts of such effects. To fully exploit the mission, another test will be launched in the fall of 2026 to visit Diros and its part space rock, Deimos. This mission is being coordinated by ESA and will gather detailed information on the interior designs of the space rocks. A lander will analyze the effect site in detail and document the details of active tracks and chemical changes on the space rock. How long would we have in an emergency? Unfortunately, in the most recent 10 years, 2 space rocks have arisen out of the blue and caused damage that could never have been predicted. The precarious thing about smaller asteroids is their small size. With an estimated measurement of a couple of meters, they often stay imperceptible even to the best telescopes. One such space rock detonated over the Russian city of Chelyabinsk, obliterating thousands of windows with a shock wave. Many individuals who hurried to the window at the strange commotion were caught, they endured slashes, and many houses were damaged. This space rock was a couple of meters in size, but then caused outrageous harm. Might you imagine what a space rock the size of a disconnected house or a football stadium could do? The Chicxulub space rock that cleared out the dinosaurs around 66 million years ago likely had a diameter of around 15 kilometers. At the point when such a hunk of rock races through the Earth's atmosphere and raises a ruckus around town Earth's surface with a thunderbolt, the impacts are prophetically catastrophic. The Chicxulub comet hit the water, which dialed it back a bit. Anyway, the effect set off a tremendous tsunami that went around the entire world. The time we have in the event of a space rock influence depends vitally on the size, speed, and distance of the divine body. Bigger space rocks can be noticed years or a very long time in advance if their orbit is known. By and by, the truth remains sobering. Specialists estimate that as little as 40% of near-Earth objects with diameters greater than 140 meters are currently recorded, and these objects can be pulled out of their known orbits and, on an impact course with Earth, at any time by gravitational movements within the solar system. The object Oumuamua was also a disturbing warning. The roughly 1 kilometer-wide object, which has not yet been identified in more detail, only pulled in the attention of space experts when it passed the Earth at a close distance. Oumuamua was so deceptive because it absorbed no light. The protrusion could have raised a ruckus around town. The travel distance of around 24 million kilometers is ludicrously small in a grandiose setting. Consider the possibility that we found an object of this size just hours or a couple of days before impact. The time we would have left would be so minimal that disaster would be undeniable. Will Apophis annihilate humanity? Any individual who names a space rock after the Egyptian lord of tumult and annihilation understands what they are dealing with. The space rock with the official name 99942 Apophis was first spotted by an observatory in Arizona on June 19, 2004, and then immediately became the focal point of science and the public. The confusion and discussions about Apophis have changed a few times since that point. Is this space rock the next one to raise a ruckus around town, or not? After its discovery in 2004, space experts determined a 1 in 37 chance that Apophis could slam into Earth on its next flyby on April 13, 2029. This number sparked worldwide concern. Apophis has a width of around 340 meters and an estimated mass of 27 million tons. A crash would have released an energy of 12,200 megatons of dynamite, which would be enough to destroy a whole continent and cause huge harm worldwide. Further observations, orbital calculations, and the risk of an effect in 2029 could initially be precluded. Anyway, it's clear that Apophis 2029 will pass surprisingly close to Earth. It will approach to about 31,000 kilometers, drawing closer to us more than many satellites. If Apophis 2029 passes through a vital area of 600 meters in width, its orbit could be changed so that an impact would happen just 7 years later. In 2021, NASA introduced further computations and the likelihood of an impact in the next 100 years was finally excluded. Apophis was removed from the warning list but remains under observation. We currently already have a test on its way to Apophis. In a couple of years, the OSIRIS-RX mission will bring rock samples of Apophis back to Earth so that we are ready in case of an emergency. Knowing the specific composition of the space rock can serve to plan a dart-like test to push the space rock out of an impact path in time. During Apophis flyby in 2029, a number of space organizations will launch missions to study the asteroid in detail. Subscribe now and miss no new recordings.